Hey guys, so this video is going to be about projectile motion.
A projectile is any body that is given an initial velocity and then follows a path determined entirely by the effects of gravitational acceleration and air resistance. The trajectory, which is pink, is the path taken by the projectile.
Some examples of projectile motion include a ball being thrown off a cliff, a rock thrown into a lake, and throwing a football.
There are some basic concepts that apply to all projectile motion problems.
First, the only force acting on the projectile is gravity, thus the acceleration is always negative 9.8 meters per second squared in the y direction. As a result, the acceleration is constant and we are given the equation a in the y direction is equal to negative g, which is also equal to negative 9.8 meters per second squared.
Second, the velocity of the projectile in the x direction is the same throughout the entire time it is moving. As a result, the acceleration in the x direction always equals 0 meters per second squared. This gives us the equations a in the x direction equals 0 and vx final equals vx initial.
Third, when the velocity of the projectile in the y direction is equal to 0, the projectile is at its maximum height. The equation x final equals x initial plus v initial in the x direction times t gives us the x position when we are given the time and the initial velocity.
The equation for the velocity in the y direction is vy final equals vy initial minus g times time, and the equation for the position of the projectile in the y direction is equal to y final equals y initial plus vy initial times time minus 1/2 gt squared.
If you don't want to memorize all these equations, you can always derive them. So if you start with acceleration equals delta v over delta t, which also equals final velocity minus initial velocity over time in the y direction, then you multiply t by the a to get rid of the denominator in the right side of the equation, and then it becomes at equals final velocity minus initial velocity, and then you add initial velocity to at, and then you get the final velocity is equal to the initial velocity plus at, and because a equals negative g if you're working in the y direction, you can substitute negative g for a, and then you get the final velocity in the y direction is equal to the initial velocity in the y direction minus gt.
In order to get the position function of the projectile in the y direction, we need to use calculus. We know that velocity is equal to dy over dt. When we multiply dt by both sides, we get dy is equal to v times dt. Earlier we found that vy final equals vy initial minus gt. When we substitute that in for v, we get dy equals v initial y minus gt times dt. Then we take the integral of both sides of the equation. This will result in y final minus y initial equals vy initial times time minus 1/2 gt squared. When we simplify this, we get y final equals y initial plus vy initial times time minus 1/2 gt squared.
So similar to the first equation that we derived, if you start off with acceleration in the x direction this time, you still get delta v over delta t, which equals v final minus v initial over time, and then you multiply time again by a. So you get at equals v final minus v initial, and then if you add v initial to at, you get v final equals v initial plus at, but because we are working in the x direction this time, a in the x direction equals 0 as we previously stated, so if you plug in that to our equation, you get v final equals v initial in the x direction.
The process for finding the position equation in the x direction is very similar to that of the y direction. First, we know that v equals dx over dt, and we manipulate it to get dx equals v times dt. Then we plug in the equation that we found above, which is dx equals vx initial plus at times dt. Then we take the integral of both sides, and that gives us x final minus x initial equals v initial x times time plus 1/2 at squared. Simplifying this gives us x final equals x initial plus v x initial times time plus 1/2 at squared. We know that a has no effect on horizontal movement and it equals 0, so when we plug that in for a, we get x final equals x initial plus vx initial times time.
When solving projectile motion problems, you can follow these steps in order to make things easier.
First, sketch a picture of the problem so that you can visualize what's happening.
Second, you should set your coordinate axes so that you can break the problem up into x and y components.
Third, list your knowns and unknowns. In projectile motion problems, these should include velocity, time, position, and acceleration.
Next, pick equations that you will be able to use to find unknown variables.
Finally, solve the equations for the unknown variables.
So our problem states that a golf player is standing on the top of a cliff that is 100 meters tall and hits a golf ball at an angle 50 degrees from the horizontal with an initial speed of 20 meters per second.
First, we need to find the total time that the ball is in the air.
Part B of the problem is to find how far in the x direction does the ball travel.
Next, we need to find the maximum height of the projectile.
The last part is to find the final velocity of the ball in both the x and y directions.
This is a list of some of the knowns and unknowns. Here are some others. First, we solve for the initial velocities in the x and y directions. Because we know that the initial velocity is 20 meters per second and that we have an angle of 50 degrees, we can break it down into components. Using cosine, we can find the initial x velocity in the x direction because cosine is equal to adjacent over hypotenuse. We know that the hypotenuse is equal to 20 meters per second. So when we plug that in and multiply it by cosine of 50 degrees, we get an initial x velocity of 12.8557 meters per second.
In order to solve for the initial velocity in the y direction, you have to use trig, and in this case you must use sine. So sine theta equals opposite over hypotenuse, and here theta equals 50 degrees, and the hypotenuse is known. It's the initial speed, so 20 meters per second. So if you solve for that, sine 50 degrees equals opposite over 20 meters per second, and then you multiply 20 meters per second by sine 50 to get the opposite value, which is the initial velocity, so which is equal to 15.321 meters per second.
Next, we need to find the time that it takes for the projectile to reach its maximum height. We know that the velocity at the peak is equal to 0, so we use the velocity equation in order to solve for time. So we can plug in the values that we've already found. We know that the initial velocity in the y direction is equal to 15.321 meters, and g is equal to 9.8 meters per second squared. So we're able to plug those in, and we get 0 meters per second is equal to 15.321 meters per second minus g times t. When we manipulate that and set g times t equal to 15.321 and divide 15.321 by g, we're able to get t. Once we do this, we find that t is equal to 1.563 seconds.
To solve for the maximum height, we will use the equation y final equals y initial plus the initial velocity times time minus 1/2 gt squared. So when you're substituting in your values, your initial y value will be 100 meters because the ball is resting on a cliff that is 100 meters tall. And then your y final will be the place where the ball reaches the top of the projectile, not the place where the ball reaches the ground. And then you will substitute the initial velocity with the values that we solved for earlier, as well as the time that we solved for earlier. So it'll be y final equals 100 meters plus 15.321 meters per second times 1.63 seconds minus 1 half g times 1.563 seconds squared. And then if you solve all that out, it equals 111.9734 meters.
Next, we have to solve for the time that it takes the projectile to go from its maximum height to the ground. We have to use the position function because we don't know the velocity of the projectile right before it hits the ground. So we use the equation y final equals y initial plus vy initial times time minus 1 half gt squared. And then we plug in the values that we know. We know that our y final is going to be 0 because our ground is at 0. We know our maximum height, which is y initial, is equal to 111.9734 meters. Our initial velocity is 0 because that's what the velocity is at the projectile's maximum height. We don't know our time, and we know that g is equal to 9.8 meters per second squared. When we solve that out, we get 111.9734 meters is equal to 1 half gt squared. And then we find that t squared is equal to 22.8517 seconds squared. When we take the square root of that number, we find that t is equal to 4.7803 seconds.
To evaluate total time, you just need to add the time the ball takes to get up on the projectile and to reach the ground. So the first value is 1.563 seconds, and then you just add that to T2, which equals 4.7803 seconds, and then you get the total time, which is 6.343 seconds.
We also need to solve for the final velocity in the x direction. As we previously stated earlier in the video, the velocity in the x direction doesn't change, so our initial velocity will equal our final velocity. As a result, we know that the final velocity is equal to 12.8557 meters per second.
To solve for the final y velocity before impact, we will use the equation Vy final equals Vy initial minus gt. So we are going to use the ball at the top of the projectile at the maximum height. So our Vy initial will be 0 meters per second because at the top it has no vertical velocity, minus g times 4.7803 seconds, which is the time for it to come back down as we solved for earlier. And if you solve for that, you get Vy final is equal to negative 46.847 meters per second.
Finally, we have to solve for the total displacement in the x direction. We use the equation x final equals x initial plus v initial x times t plus 1 half at squared. Then we plug in the values that we already know. We know that x initial is equal to 0, v initial x is equal to 12.8557 meters per second, time is equal to 6.343 seconds, and acceleration is equal to 0. This gives us x final equals 12.8557 meters per second times 6.343 seconds, which equals 81.5476 meters. We thank you for watching our video, and we hope that it helped you learn more about projectile motion.